since we're ready, everyone's ready. So, class,
Yes.
Christian,
Yes.
Juju. You're like super, yeah. Okay. All right. So since I have everyone's attention now, let's go ahead and I am going to show you how to get the derivative of tangent to equal secant squared. So we know from yesterday's lesson that tangent is y over x, right? It's sine over cosine, isn't it? Okay, so I'm going to start with that. So I'm going to say that I want to have my function is going to be y equals sine x over cosine x. Now I'm going to go through and I'm going to start taking the derivative of this. So this is, so f is sine x, f prime is cosine x, g is cosine x, g prime is negative sine x. So I'm going through and doing my quotient rule, and I'll write out the quotient rule for you again. So f prime g minus g prime f over g squared. Yes, no, maybe? Okay. All right, so I'm going to start plugging in. So f prime is going to be cosine x times g, which is cosine x, minus g prime, which is negative sine x, times f, which is sine x. And all this here is going to be over g squared, which is cosine squared x. Now, in the numerator, I got negative, negative, so I'm going to change that to a plus sign right there. So I'm now going to have cosine squared x plus sine squared x over cosine squared x. And what is the one thing you learned yesterday? What is the one thing I should be able to identify here? Numerator is equal to 1 because sine squared plus cosine squared is going to give me 1. So that turns into 1 over cosine squared x. So technically, I could say that this is going to be the derivative here. So do I actually have to turn it into secant squared? No, you don't have to. I could leave it as 1 over cosine squared because that's the same. That is an equivalent answer. Because sometimes you might actually need that. You might need that for whatever problem that you're doing. You might need some substitution using that information. So, and we know because it's a reciprocal, cosine is the reciprocal, no, secant is the reciprocal of cosine. So this is just going to turn into secant squared x. I like how these problems just always just work out. They like, bam, goes from this big complicated thing down to 1, then there we go. Now, trigonometric functions, derivatives, and the domain of the derivatives. Because when we start talking about the inverses of the derivatives, you need to know what the domain is, and to be able to actually calculate this So sine turns into cosine, cosine, negative sine, tangent goes to secant squared, cotangent is cosecant squared, cosecant is negative cosecant cotangent, and secant is going to be secant tangent. So we did these first three, but now these next three right here, I can find those ones there just by using the quotient rule. Do you need to memorize them every time? No, I don't have them memorized. When I see it, I'm like, okay, I'm gonna have to do this, I'm gonna have to do the quotient rule. It's going to take a little bit longer, but so you are always correct. You will know you're always correct and not just guessing if you don't have it completely memorized of what these are and how we get them. The quotient rule is going to get me those every time. Evaluate the second derivative of a trigonometric function. Find f double prime pi over 4 if f of x is equal to secant x. Okay. I could use the quotient rule and I could actually do that, or was I just given the secant already? Do I know what the derivative of secant is? Was I just given the derivative of secant? Yes, I was. So could I use this one? Yeah. So my first derivative, because it's going to be asked for the second, so I'm going to say that my f prime of x is going to be secant tangent. Now to do my second derivative here, what's happening in between the secant and the tangent? Christian, what's happening there? What's the operator that's going to be in between those two things? Multiplication, very good. So if it's a multiplication, then I know that my next step has to have a product rule. So if it's going to have a product rule, let's go ahead and do my product rule. So this is going to be my f, this is going to be my g. So f is going to be secant x, so f prime is going to be secant x tangent x. G is tangent x. G prime is going to be, derivative tangent was secant squared. Now I can plug that into my product rule. So my product rule is f prime g plus g prime f. So I'm going to have secant x times tangent x g tangent x plus g prime, which is secant squared, times f, which is secant. Now that looks pretty long, complicated, and nasty, isn't it? It could be. We have a bunch of secants and a bunch of tangents, but now I need to know some trig right here. Secant is 1 over cosine, right? Tangent is sine over cosine, right? Okay, so let's rewrite this. So I'm going to rewrite this with what I know. So it's going to turn into 1 over cosine times sine over cosine times sine over cosine plus 1 over cosine squared times 1 over cosine. turns into sine squared cosine cubed. And over here, do I got cosine cubed again? Yes, I do, because I have a common denominator. Okay, so I'm going to take this over to the next page. So sine squared there you go. So this is my second derivative. And my question said I had to find what? Pi over 4, right? Okay. So on my unit circle, so I'm just going to look at the quadrant 1 here. Pi over 4 is right here. And I know at pi over 4, rad 2 over 2, rad 2 over 2. Alright, let's try it out. F prime, dou prime at pi over 4 is equal to sine, which is going to be rad 2 over 2 squared plus 1 over rad 2 over 2 to the third. So what's that going to be? If I square rad 2 over 2, that's going to be 1/2, because the square is going to cancel out the square root, and the 2 becomes a 4. So it's going to end up becoming 2 over 4, which is 1/2. 1/2 plus 1? 3 halves. Yes? Did I lose you on that one, Vincent? Kinda? So, are you okay with this being 1/2? Yes? And then I'm adding 1, which is 2 halves. Because that's 2 over 2, isn't it? So yeah, just combine it, we get 3 halves. Now the bottom is going to be kind of a mess, right? So rad 2 over, so as I expand this, this is going to give me rad 8 over 2 to the third power. 2.2 is 4 times 2 again is 8. Right? Okay, can I factor anything out of there? A 4, right? 4. So that's going to give me 2 rad 2 over 8, which will reduce by factor 2, right? And I get rad 2 over 4. And I got fraction over fraction. And since I have fraction over fraction, I am going to multiply by the reciprocal. So it's going to be 3 over 2 times the reciprocal of the bottom, which is 4 over rad 2. So 6 over rad 2, then rationalize, times rad 2, 6 read 2. All of that work, just simple it down to 3 read 2. Are we okay there or no? Kinda? Maybe? Was that the last part of the question? Yeah, that's it. Now, so on this one right here, you know what? I want you guys working on the homework. I'm going to skip this one here because this is just a long word problem doing exactly the same thing that we did. So finding this and reading through there. So, and you have another problem like this in the homework. So I want to see if you guys could actually do this one. So I'm going to leave off here. So that means if we're finishing today, that means homework is going to be due on Monday. Because tomorrow's Friday, right? Yes. Homework's going to be due Monday. Alright. Make sure you like, share, and subscribe.